Hello, this is the fifth video of the second order differential equations series 2 on non-homogeneous equations for OCR Pure Core Further Mathematics. And we'll be looking at the particular integrals of exponential functions. As we've covered in previous videos, in order to solve these second order differential equations, we find the complementary function and then look for a particular integral, which we do by trial of a similar function to f of x to give the general solution. Let's use a similar example to previous videos, only in this case f of x is 3e to the minus 2x. We already know that the complementary function will be y equals ae to the 2x plus be to the minus x. So let us try a particular integral y equal to some constant a times e to the minus 2x. Then dy by dx will equal minus 2a e to the minus 2x, and the second derivative will equal 4a e to the minus 2x. Putting those into the equation would give us 4a e to the minus 2x minus 2a e to the minus 2x minus 2 lots of the y a e to the minus 2x, which would equal 3e to the minus 2x. Dividing through by the factor of e to the minus 2x would give us 4a plus 2a minus 2a equal to 3. So a will equal 3/4, and the particular integral will be y equals 3/4 of e to the minus 2x. This leads to the general solution, the combination of the complementary function and the particular integral of y equals ae to the 2x plus be to the minus x plus 0.75 or 3/4 e to the minus 2x. Looking at this GeoGebra file, we can see that the blue line is the first term of the complementary function, and the green line is the second term, with the particular integral shown as the orange line. So, dependent on the values of the arbitrary constants a and b, the y graph will be dominated by one or other or combination of these terms. We can see that if x increases in a positive sense, then y, or the graph, will tend to ae to the 2x. If as x increases in a negative sense, then the graph will tend to the 0.75 e to the minus 2x, in other words, the particular integral component. You would imagine it would normally tend to the second component of the complementary function, but in this particular case, the e to the minus 2x dominates the e to the minus x term. So as we vary a and b, we can see that the graph y still lies between the envelope graphs of its components. Let's see what happens when a is negative, and if b is also negative. Here we can see that when a is small and negative and b is positive, that the curve y looks similar to the particular integral component for x less than 0, but tends towards the first component of the complementary function as x is positive. So in our table of the trial functions we would use for particular integrals, we have now added the trial function ae to the px for all exponential function f of x. This table now shows most of the important cases in terms of standard functions on the right-hand side of non-homogeneous second-order differential equations. In the next video, we will consider special cases for particular integrals.